Okay guys, let's talk about similar polygons today. These are similar polygons. They have the exact same shape, but in this case, different sizes. One thing we first do, we have to label the vertices, and we always use capital letters for the vertices of polygons in our geometry. So in this case, I've labeled them A, B, C, and D, and E, F, G, and H. Now, we need to know how to read this and understand that these segments, this side, this top right side of this particular shape, AB, segment AB, is similar to segment EF. Notice they're in the exact same position of the two polygons. It's easiest to do when they are in that exact same position. So again, AB, segment AB is similar to segment EF. And of course, segment BC is similar to segment FG, again in the exact same position. Of course, that is true about CD being similar to GH, and DA is also similar to HE. So let's apply some math to this. Here we have two triangles. In the instructions on this problem, it would say that this shape is similar to this shape. They look like right triangles, and our numbers will show that, but that's not really relevant to what I'm showing you today. How to figure out a missing side, we'll get to that. Proportional means having a constant ratio to another quantity. Know your definitions in math. Okay, so these shapes are similar. The sides are proportional. If we know that, then we can determine missing side lengths. We'll add some numbers now. Okay, so we have all three sides of this right triangle, but we only have two of the sides of this right triangle. So we will be able to solve for this side knowing that the shapes are similar or proportional. Here the shortest sides of the triangles are proportional in the same way the bases are, and I'm calling this 12 and this 24 the bases. And the diagonals must be as well. If two sides are proportional, all three sides of a triangle would definitely be proportional. So this is how that is set up. If I can take the shortest side over the shortest side, and that's definitely going to equal the second shortest or second longest side to the second longest side of the other shape. So that's the easiest way for me to get kids to set this up. Short side over short side, next longest side over next longest side would be one way to set it up. But knowing that all three sides are proportional, I could also set it up. Shortest side over shortest side will equal the longest side over the longest side. Or I could say shortest side over shortest side will equal the hypotenuse over the hypotenuse if it's a right triangle like these two are. So now this is where we use cross multiplication to solve for this x. Remember, cross products have equal values if two fractions equal each other. So if I simplify this, this is going to be 1/2. This definitely will simplify to 1/2 also because they equal each other. But we use cross multiplication because the numbers get tougher than this. So that's what it looks like. The 5, the numerator, will times the denominator of the other fraction will equal the denominator times the numerator of the other two fractions. I didn't say that right, but you know what I mean. So we have it set up. Numerator times denominator equals numerator times denominator. I just wrote it in the other order. I then start to solve it, so 5 times x, of course, is 5x. 10 times 13 is 130. And we're left with just one step to finally solve this one and determine what x's value is. So we divide by 5, the number on the variable, as always. Divide 130 by 5, and we get x equals 26. We now know for sure that this hypotenuse, or this longest side of this triangle, is 26 units, or whatever they might be labeled. In this case, just units. Thank you so much for your attention. You can learn this. Please watch again if you feel you need it. And have a great day.